Okay, now I would like to show you example from the previous problem. Okay, actually the previous problem we got the result. Okay, for this problem, we got the result of the D is negative 1.36 meter. Actually, what the meaning of negative? Okay, since we plot here, okay, the D is on the left of point B. Okay, the A is on the left point B. Okay, so the D is negative 1.36. The negative means that actually this point A is on the right of the point B. Okay, that's meaning, so if you put A on the right, so we get the result here as positive. Since we put here F on the left, so we got here negative. So next problem, okay, similar question but similar system but different question. Okay, now we have point B here, okay, but we have another point A. There is 1.36 meter to the right of the B. Okay, because I follow the result from the previous problem, and another point C here. So the question here, replace the loading system, okay, with a single loading, okay, at point A, point B, and point C. Okay, so now in this system we have 4 loading, 450 Newton, 300 Newton, 700 Newton, and 1500 Newton meter. Okay, 3 forces and 1 moment. So we want to replace this 4 loading become a single loading, okay, at point A, at point B, and point C. Okay, how we going to do this? Okay, first let me find out what is the single loading system at point B. Okay, at point B here. Okay, so the first step we need to get the summation of the force. Okay, force summation. Okay, so we get the total of forces in S direction is going to be, so we need to resolve, okay, these forces to S and Y direction first. All right, bit crowded here. Okay, so we get here the first forces is 450 Newton. Okay, it cosine 60 degree minus 700 sine 30 degree. So we get here is equal to negative 125 Newton. And total forces in Y direction is, we have the first one is 450 Newton sine 60 degree. Downward is negative. And then we have minus 300 Newton. And then we get downward, okay, 700 Newton cosine 30 degree. Okay, it's going to be minus 1296 Newton. Okay, and the resultant force for this component to be 125 square plus 1296 square, we get 1302 Newton, with the direction of inverse tangent of 1269 over 125 equal 84.5 degrees. So become, see, it's negative, so this direction to be in third quadrant. All right, okay, next moment summation, okay, at point B. Okay, moment summation at point B. First we have the moment at point B, okay, is equal the total of moment created, developed by all the loadings is equal to, so first we have this downward force, okay, 450 Newton sine 60 degree, okay, with the perpendicular 4 meter. Okay, this one is on the point B 0, and then we have 700 Newton. 700 Newton cosine. Okay, previous program I forgot this cosine 30 degree. Okay, with the perpendicular distance is 3 meter. Okay, it's counter is clockwise, so in negative, because counterclockwise is positive. Okay, and then we have 1500 Newton meter clockwise, so in negative. So here we get the amount of the moment is negative 13 Newton meters, okay, or 1358 Newton meter clockwise. Okay, so if you draw the new system, okay, this point B, okay, so we have the force is 1302 Newton at the angle of 84.5 degree, and we have the moment of 1358 Newton meter, okay, clockwise. Okay, so this system and this system equivalent. Okay, next, that we do on the point C. Okay, that we do a point C. At point C, okay, similar to previous one. Okay, similar to previous one, we have force summation. Okay, force summation. Okay, is similar. We have get the total of Fx is equal to 1-125 Newton. The total of Fy equal -1296 Newton. Okay, and we get the Fr is 1302 Newton. Okay, and the direction is 84.5 degree. Okay, and then the moment summation, okay, a bit different. Okay, because it have at the different location here. Okay, so the moment counterclockwise is positive, the moment at point C is equal. All right, so the first force, the loading is the 450 Newton. 450 Newton, sines 60 degree. Okay, so the perpendicular distance between I bring back here. Okay, from here to here is 2 meter. Okay, so it's clockwise, so it's negative. And then we have 300 Newton. Okay, this force 300 Newton. Okay, times with the distance is 6 meter. Okay, also clockwise, so it's negative. And then we have this force. Okay, the 700 cosine 30 degree. Okay, and it also times, so the times with 2, 4, and 3. Okay, is become 9 meter. Okay, it also negative, and then we have the 1500 Newton meter clockwise. Okay, so the total moment here at point C become -7717 Newton meter. Okay, or it become 7717 Newton meter clockwise. Okay, so if you draw the system, it becomes like this is point C here. So we have the force of 1302 Newton with the direction of 84.5 degree, and the rotation, the moment is 7717 Newton meter. Okay, clear. So next, we do for the point A. Okay, point A is where we get the answers for the previous problem. Okay, where it only have a single force, no moment. Okay, so let me find out. Okay, what is the point A, the equivalent system at point A. So again, get the summation of the forces. Okay, similar to previous one, we are going to have the total of Fx, okay, equal 125 Newton. Total of Fy equal 1296 Newton. So the Fr is equal to 1302 Newton. Okay, the direction is 84.5 degree. Okay, and then the moment summation here. All right, the moment summation is the total of moment counterclockwise positive moment at point A equal to, okay, so we have first the 450 Newton, okay, sine 60 degree with the distance, okay, okay, with the distance from here to A. So 4 meter plus 1.35 is going to be 5.35 5.36, sorry, 5.36, okay. It's counterclockwise positive. Next we have 300 Newton time with 1.36, okay. It's also counterclockwise positive, and then we have 700 cosine 30 degree, okay, time with from here to A is to be around 1.64 meter. It's clockwise, so it's negative, and then negative 1500 Newton meter. So the result we get 0.6 Newton meter, okay. Okay, we assume is nearly to zero, okay. So if you plot this system, okay, at point A, we only have the force of 1302 Newton at angle of 84.5 degree. So there is no moment acting at point A, okay. So if we compare these three systems here, okay, okay, at point C, point A, and point B here, okay. Actually, these three system is equivalent, okay. What make the difference is the moment, okay. At here the moment is 7717, at here the moment is 0, at here the moment is 1358. So if one do the analysis, okay, we can do understand, okay, if we move the force, we need to add the moment, okay, but the force is still similar, okay, 1302, 1302, 132. So this is what the meaning of system equivalent. So we want to find out what is the total loading at each point, whether at A, B, or C. So we do understand the loading at each point, okay, on an object, okay. So this is the purpose of the equivalent system. Okay, thank you.